Hey guys, we are going to be dividing radicals this week. So here are some examples to help you with your at-home learning. First of all, some things to remember. The first thing is when you're finished, they cannot be divisible by any perfect square. Okay, so when we look at the actual end product, they cannot be divisible by any perfect squares. You can't, in other words, pull anything out from underneath the radical. Number two, they cannot have a radical in the denominator. Okay, we will deal with that in the second part of this lesson, but you cannot have a radical in there for underneath in the denominator. And number three, all fractions must be simplified or reduced. So here is the overall property that we're dealing with today. Division property of square roots. If the square root of a over b is what we're looking at, that will be the same thing as the square root of a over the square root of b, which then allows us to start computing with it. So you take the radical of the numerator and the radical of the denominator. So let's start with the two perfect squares here to make it easy. So the square root of 64 over 49 really equals the square root of 64 and the square root of 49. That's what that really means, right? Well, the square root of 64 is equal to 8, and the square root of 49 is equal to 7. So the square root of 64 over 49 is 8 over 7. Okay, let's bring in some variables here. So the square root of 25y to the third over z squared really equals square root of 25y to the third over the square root of z squared. Now, the square root of z squared, we know, we've already talked about this. If you square something, but then turn right back around and square root it, you're left with the original z. All right? And then up top, let's take a look here. When we were simplifying these radicals earlier, we started with the numbers. So the square root of 25 it's a perfect square, so that's 5. That can come out. And there's 3 y's. So there's a pair and then 1 left over. So we pull the pair out and just put it as 1 y. And then there's 1 y left over, so the square root of y is left underneath. So this is my final answer. Okay, so we are simplifying these and pulling out perfect squares. Okay, now, but what happens when the denominator is not a perfect square? What happens if there would still be some leftover under the radical underneath? Because as you remember, one of the first slides, it says you cannot have a radical in the denominator at all. So that's where we need to remove that radical in the denominator by a process called rationalizing the denominator. Okay, now let's see what that looks like. Number one, simplify your fraction first, if that's easier for you. Number two, multiply the top and the bottom by the radical in the denominator. Not everything in the denominator, just the radical. And then 3, simplify again. So let's practice. Let's start with a less complicated one. So the square root of 3 over 7 gives me the square root of 3 over the square root of 7. Now, in our first example, they were perfect squares, but now they're not. So we have to get rid of that square root of 7. So we multiply the bottom and the top by the square root of 7. Why? Why does that work? Why does that help us? Aren't we trying to get rid of the square root underneath in the denominator and underneath the fraction bar? Yeah. So a square root of 7 times a square root of 7 leads me to the square root of 49. Wait, but isn't that just 7? Yes. So in other words, A shortcut way of thinking about it, guys, is when you square root multiplied by a square root of the same number, you end up with just that number. So it basically makes the square root disappear. So now there's 7 at the bottom. At the top, we do the square root of 7 times the square root of 3, which we know is the square root of 21. Now, can any perfect squares be pulled out of 21? No. So here's my answer. Square root of 21 over 7. All right, let's take a look what this would look like with some variables in it. Okay. So if you would like, you could simplify this first and do, if you would like, so we have the square root of 8a over the square root of 2a to the 5th. All right, so simplifying first, this would be the square root of 4 and the square root of 2, right? So you could pull out that 4, which would be a 2 on the outside. The a can't be pulled out, and that square root of 2 would be left. So square root of 2a at the top, okay? Now let's look at the bottom. The square root of 2 can't be pulled out, but look, if there's 5 a's, that's 2 pair. So a squared can be pulled out, and there's an a left and a 2 left. Okay, now there's a shortcut on this one. Yes, we could rationalize the denominator by multiplying both the top and the bottom by the square root of 2a, and then we would have to do more simplifying. But a shortcut for one like this, you guys, 2a over 2, square root of 2a over square root of 2a is done. It's crossed out. That would equal 1. Same thing over the same thing equals 1. So that cuts a lot of work out for us. So my final answer is just going to be 2 over a squared. Can I pull out any perfect squares? No. Are there any square roots under the or in the denominator? No. So I'm done. Okay? That would be a shortcut for ones like this. All right, let's take a look at this one. So again, this equals, because of the division property here, 6, the square root of 6 over the square root of 8n. Okay, now we can simplify here. Square root of 4 over the square, and the square root of 2. Square root of 4 is 2. That comes out from underneath the radical. I can't pull out n or 2, so I just leave square root of 2n underneath. And I can't reduce this at all, so that's 6. Now, I still have a radical underneath my fraction bar. There's still a radical in the denominator, so I have to get rid of that. So I'm going to multiply by only the radical, guys, not everything, just the radical. So square root of 2n over square root of 2n. So I'm multiplying the top and the bottom by that, okay? When I do that, I'm going to bring this down here to help organize. Okay, so 2 is still on the bottom, but the square root of 2n times the square root of 2n, as we know, is just 2n. So I'm going to multiply by 2n, okay, because there's already a 2 out there. And then this is multiplication, even though there's no multiplication sign. So when I do multiply this by this, I do end up with 2n. Now, on the top, I have the square root of 6 times 2 is 12, and then n. All right, now I have rationalized the denominator. Awesome. But I'm still not finished because I can still reduce and simplify here. So at the bottom, 2 times 2n is 4n. Okay, no problem. Now, let's simplify this radical up here. So the square root of 12, what perfect square can I pull out of that? Well, square root of 4 and the square root of 3. Awesome. So the square root of 4 is 2, so the 2 comes out. The n cannot come out, and neither can the 3, so square root of 3n. Am I done? Not quite. Okay. Last thing I have to do is I need to simplify the 2 and the 4. I can do that by reducing, and it would be 1 over 2, so I can ignore the 1. I don't have to put it. 3 square root of 3n over, and this becomes a 2n. Final answer. I can't reduce the n's because the n is underneath the radical here, and this is not underneath the radical. So those mean different things. So that is my final answer. Okay, let's take a look at this one. The top one doesn't have a radical in it at all. Okay, so we have to rationalize this. We got to get that square root of 11 gone. Okay, it cannot stay a radical. So I'm going to rationalize oops. Okay, I'm going to rationalize the denominator here by taking the square root of 11 times the square root of 11. But you guys got to do it on the top too. You can't just do it at the bottom, okay? So the 11s, well, that just becomes 11 as we've learned. And we've got 22 times the square root of 11. So 22 times the square root of 11. But if this was my final answer, what would be wrong with it? Hopefully you're saying that it's not simplified. You'd be right. So 22 over 11 reduces to 2 over 1. So I can put a 2 square root 11. And I don't need to put that 1 underneath because that could just be assumed. And I'm done. All right, stick with me, guys. We got one more. You guys are doing great. Okay, square root of 5 over 18n. Okay, this one gets fun. Let's do this one together, okay? If you want to try this, pause the video right now. Try it. See if you get what I get. Okay, so this really equals the square root of 5 over the square root of 18n. We'll start there. Okay, I can simplify this first. Square root of 9, square root of 2. The 3 comes out. So I've got 3 and then square root of 2n. Now the top I can't reduce at all, so that's just square root of 5. Okay, I cannot have that square root of 2n there down below, so I need to multiply by only that. Square root of 2n. Square root of 2n. Okay, we know that when we multiply a square root times itself, we end up with just what's underneath. So I'm really looking at 3 times 2n at the bottom. And then the square root of 10n. 5 times 2 is 10, and then the n is left. All right, so let's keep going. I'm going to come down here. I'm going to bring this down so you can follow me here. By the way, 3 times 2 is 6n. Okay? Can this be reduced? Is there a perfect square to pull out here? No. Is there a radical in the denominator? No again. So my final answer is the square root of 10n over 6n. And remember, you cannot reduce the n's here because one is underneath a radical and another one is not. So they mean different things entirely. Okay? I hope this helps with the dividing radicals this week. Please reach out to your teachers if you have any questions, but this video should answer a lot of the main questions for you. Have a great week, guys.